Projective Geometry, Volume 1, by Oswald, Veblen, and John Wesley Young. Chapter 4, Harmonic Constructions and the Fundamental Theorem of Projective Geometry. Section 31, Exercises. Prove Theorem 4 directly from a figure without using Theorem 2 of Chapter 3. 2. Prove Theorem 5 Corollary 2 directly from a figure. 3. Through a point given in a plane, construct a line which passes through the point of intersection of two lines in the plane without making use of the latter point. 4. A line meets the sides of a triangle ABC in the points A1, B1, C1 and the harmonic conjugates A2, B2, C2 of these points with respect to the two vertices on the same side are determined so that we have H of AB, C1, C2, H of BC, A1, A2, and H of CA, B1, B2. Show that A1, B2, C2, B1, C2, A2, C1, A2, B2 are collinear, that AA2, BB2, CC2 are concurrent, and that AA2, BB1, CC1, AA1, BB2, CC1, AA1, BB1, CC2 are concurrent. 5. If each of the two sides AB, BC of a triangle ABC meets a pair of opposite edges of a tetrahedron in 2 points which are harmonic conjugates with respect to A, B, and BC, respectively, the third side, CA, will meet the third pair of opposite edges in 2 points which are harmonic conjugates with respect to CA. 6. If A, B, C, D are the vertices of a quadrangle, the sides of which meet a given transversal L in the 6 points P1, P2, P3, P4, P5, P6, the harmonic conjugate of each of these points with respect to the 2 corresponding vertices of the quadrangle is constructed, and these 6 points are denoted by P1', P2', P3', P4', P5', P6', respectively. The 3 lines join the pair of the latter points which lie on the opposite sides of the quadrangle meet in a point P, which is the harmonic conjugate of each of the points in which these 3 lines meet L with respect to the pairs of points P' defining the lines. 7. Defining the polar line of a point with respect to a pair of lines as the harmonic conjugate line of the point with regard to the pair of lines, prove that the 3 polar lines of a point as the pairs of lines of a triangle form a triangle, called the cogredient triangle, respective to the given triangle. 8. Show that the polar line defined in Exercise 7 is the same as the polar line defined in Exercise 3 of page 52. 9. Show that any line through a point O and meeting 2 intersecting lines L and L' meet the polar of O with respect to L, L' in a point which is the harmonic conjugate of O with respect to the points in which the line through O meets L, L'. 10. The axis of perspectivity of a triangle and its cogredient triangle is the polar line, chiefly page 46, of the triangle as to the given point. 11. If 2 triangles are perspective, the 2 polar lines of a point on their axis of perspectivity meet on the axis of perspectivity. 12. If the lines joining corresponding vertices of 2 n-lines meet in a point, the points of intersection of corresponding sides meet on a line. 13. Generalization of exercises 7 and 10. The n polar lines of a point P as the n-1 lines of an n line in a plane form an n-line, the cogredient n-line, whose sides meet the corresponding sides of the given n-line in the points of a line P. The line P is called the polar of P as to the n-line. Footnote: this is a definition by induction of the polar line of a point with respect to an n-line. 14. Generalization of exercise 11. If two n-lines are perspective, the two polar lines of a point on their axis of perspectivity meet on this axis. 15. Obtain the plane duals of the last two problems. Generalize them to 3 and n-dimensional space. These theorems are fundamental for the construction of polars of algebraic curves and surfaces of the nth degree. Projective Geometry, Volume 1. This book was written by Oswald, Veblen, and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renholt, with programming and illustration by Jim Renholt, 2019. Thank you for listening.